Hello viewers, welcome to this session. Here we are discussing three examples. First one is very important, how to find the direction ratio and direction cosine of a vector. Here the vector is given A is equals to 2i minus 3j plus 6k. So first of all, we have to find the magnitude. So magnitude is equals to root over x square plus y square plus z square. Here x is 2, so 2 square, y is minus 3, z is 6 square. So 4 plus 9 plus 36, adding up 49 is equals to 7. So unit vector, now we have to find the unit vector, that is vector A by its magnitude. So you can write as 2 by 7 because first component of I is 2 and the magnitude is 7. So 2 by 7 I minus 3 by 7 j plus 6 by 7 k. So now we are ready to get the direction cosines. First of all, direction ratio. Direction ratios are 2, minus 3 and 6. So we write direction ratios are 2, minus 3, 6, and direction cosines two by 7, minus 3 by 7, 6 by 7. Next problem says for what value of m the vectors this and this are collinear. Now here for collinearity, must be equals to lambda times vector A. So lambda is a scalar. Now if you write the B, that is mj, what mi? Mi 6j minus 8k is equal to lambda times 2i minus 3j plus 4k. So if you compare the components of I, j, k, here it is m and here it is 2 lambda. Here it is 6 and here it is minus 3 lambda. Now from this relation, you can say that lambda is equals to 6 is equals to minus 3 lambda. So here we are getting the lambda is equals to 6 by minus 3, that is minus 2. And here m is equal to 2 lambda. So m is equals to 2 lambda is equals to 2 into minus 2 is equals to minus 4. So minus 4 is the value of m. Now the next sum is find a vector of magnitude 5 units. Magnitude 5 units parallel to the resultant of the vectors a and b. So First, we'll find the resultant of two vectors. Resultant of two vectors means they are sum of the vectors. So we are considering resultant of two vectors A and B is R. So R is equals to vector A plus vector B. And we know how to add their components of I along the direction of the scalar quantity 2 plus 1, then 3 minus 2, and then minus 1 plus 1 k. And we know that vector A1I, A2j, A3k, and if the vector B, B1I, B2j, B3k. So we have to add A1 plus B1 into I. So A plus B, A1 plus B1 into I. Cap A2 plus B2 into J cap A3 plus B3 into K cap. So same thing we proceed here. 2 plus 1 whole into I cap, 3 minus 2 whole into J cap, and minus 1 plus 1 whole into K cap. So 3 plus 1 is I, 3I, 3 minus 2 is 1, so 1 into J cap, and minus 1 plus 1 it becomes 0. So we got R, that is the resultant. Now vector R magnitude is root over 3 square plus 1 square. Root over 9 plus 1, so it can be root 10. So you can define a unit vector R cap is equal to 3 by root 10 whole into I plus 1 by root 10 into J. So therefore decode vector whose magnitude is 5 into the unit vector. That is 5 into 3 by root 10 I plus 1 by root 10 J. So that is 15 by root 10 I cap and 5 by root 10 into J cap. Now we'll solve a problem. Here you have to find a vector of magnitude 5 units. And parallel to the resultant of the vectors A, 2i plus 3j minus k and B this. So first of all we will find the resultant. You know the resultant is equals to say this is vector R which is equals to sum of two vectors, that is 2i plus 3j minus k cap plus I cap minus 2j cap plus k cap. So now add. So component of here 2 and the component of I is 1. So 2 plus 1 is 3 I cap plus 3 and minus 2. So only j cap. Then minus 1 and plus 1. So this becomes 0. So finally we will get 3I cap plus j cap. Now the question is you have to find a vector. Say vector P whose magnitude is 5 and parallel to the resultant of this. So we'll define a unit vector R cap here. So now here R cap, how will get the R cap? R cap is equals to vector R by magnitude of R. That is 3I plus j cap by magnitude of r, root over 3 square plus 1 square. So 3i plus j, and this is 9 plus 1, 10, so root over 10. So now the value of p is given 5 units. So we'll put up 5 and then 3i plus j cap by root over 10. So 15 by root over 10 into I cap, now plus 5 by root over 10 into j cap. So this is our required vector. Okay, thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.